And here we go, looking at lesson 3.1. We're going to be talking about graphing relationships. Our objective is matching simple graphs with situations and to graph relationships. So as we're talking about this, I hope that you're thinking, what kind of relationships are we talking about? A vocabulary we want to consider is a continuous graph versus a discrete graph, and we talked about this briefly in chapter 2 when we were looking at inequalities. And you can see that graphs can be used to illustrate many different situations. Trends shown on a cardiograph can help a doctor see how a patient's heart is functioning. To relate a graph to a given situation, we use keywords in the description. So let's look at this example one, relating graphs to a situation. Each day several leaves fall from a tree. One day a gust of wind blows off many of the leaves. Eventually there are no more leaves on the tree. Let's look to see if we can figure out which graph best represents that situation. So there are several leaves, meaning there's the most that the tree will ever have. The graph should be continually going downward until all the leaves are gone. So I believe that we can disregard graph A. The leaves will not increase in number, and that's what this graph is showing. The number of leaves increasing over time. Graph B, we see a decrease, no loss at all, and then another decrease. Our situation says a gust of wind blows off many leaves. So they fall gently, then they fall more rapidly, and then they go back to falling gently again. This flat line would not indicate a gust of wind over time. It would indicate the same number of leaves maintained on the tree over time. Keywords that we were looking at. Each day, several leaves fall. The wind blows off many, and eventually there are no more. Never horizontal, which we talked about, graph B. Slanting downward rapidly would be the loss of many leaves, and eventually no more would mean that the graph finally reached 0. Graphs A, B, and C. Picking the graph that shows all of the key phrases in order would be graph B. Now let's look at a separate relationship, the air temperature over time. At the end of the day, the temperature increased slightly before dropping sharply. Choose the graph that best represents the situation. Well, let's pick out the key terms again. Reading from left to right, over time indicates the early morning to the later part of the day. Keywords: increased steadily, remained constant, and then increased slightly before dropping sharply, slanting upward and then steeply downward. And we can go back to see those graphs showing those situations. The graph that shows all key phrases in order would be graph C. As seen in example 1, some graphs are connected lines or curves called continuous. Some graphs are only distinct points. They're called discrete graphs. The graph on theme park attendance is an example of a discrete graph. It consists of distinct points because each year is distinct and people are counted in whole numbers. The values between whole numbers are not included since they have no meaning for the situation. This is what we call a discrete graph. The number of people between this year and this year. It's not a continuation. The park's only open for a certain number of days, and this is the attendance over the year. If we look at this graph, we can see a decline in population over the years. Now let's talk about whether this is continuous or discrete, meaning connected or not connected. A truck driver enters a street, drives at a constant speed, stops at a light, and then continues. As time passes during the trip, moving left to right along the x-axis, the truck's speed is on the y-axis, and it's doing the following. We enter the street and increase our speed to where we want to maintain our speed. We're going to keep it constant at this point. Then we're going to come to the stop sign, meaning our speed should be decreasing. Then we pick up speed again to our desired speed and continue on our way. This graph is continuous. When sketching or interpreting a graph, pay close attention to the labels on each axis. Sketch a graph for this situation and tell whether the graph is continuous or discrete. A small bookstore sold between 5 and 8 books each day for 7 days. Well, on day 1 we sold 5. In between days 1 and 2, we didn't sell any books because the store was closed. On day 2 we sold 5 as well. The highest days were the 4th and the 5th day. There should be no amount of books sold, not a half book, a partial book. There's only whole numbers of days and whole numbers of books. Therefore, this would be considered a discrete graph. I want you to check it out. Example 2A. Sketch a graph for the situation. Tell whether it's continuous or discrete. And then come back here and check your solution. So Jamie is taking an 8-week keyboarding class. At the end of each week, she takes a test to find the number of words she can type per minute. She improves each week. Each week she has a new score at the end of the week. The days of the weeks, we're not counting in between, we're just counting at the end of week 4, 1 score. The scores are not continuous. They only give 1 rate per week. Therefore, this is a discrete graph. Try check it out 2B and then come back to check your solution. Henry is going to drain a water tank by opening a valve. Then he opens another valve. Then he closes the first valve. He leaves the second valve open until the tank is empty. So we know that the water level does not jump from 4 feet to 3 feet to 2 feet. It takes on every measure in between 4 and 3 feet slowly as the valves are being opened. So we consider this a continuous graph because every level is being recorded. Both graphs show a relationship about a child going down a slide. Graph A represents the child's distance from the ground related to time, and graph B represents the child's speed related to time. Write a possible situation for this given graph. Identify the labels. X-axis is time and the y-axis is speed. Analyze the sections over time and the speed. We initially decrease, then we remain constant, and then we decrease to a speed of 0. A car approaching a traffic slows down, drives at a constant speed, and then slows down until coming to a complete stop. Try check it out number 3. Write a possible situation for this graph. Well, we see that the number of pizzas bought are related to the number of students on the x-axis. So as the number of students is increasing, the number of pizzas bought will also be increasing. Identify x-axis as students, y-axis as pizzas. As students increase, the pizzas do the following. Initially, they're remaining constant, but at a certain point, the number of students increased so much that we needed to increase the number of pizzas bought. Yum, yum. Write a possible situation for the given graph.